The final part of our exam review will cover essentially a mock test. Your exam is going to look very, very similar to this, except it's going to be multiple choice. But you still need to know how to do the math. So that's what we're here to do. Okay. So it's probably going to be really long. It's a long exam. It's going to be 90 minutes. So let's get going. All right, multiply. Number one is a multiply problem. So when you're multiplying polynomials like this, what you're going to do is you can either set up a little table like 2x and -5 times 3x and 4. You can set up a little table like this and start doing the math. 2x times 3x, remember you're multiplying, okay? So that's 6x squared. 2x times 4 would be 8x. -5 times 3x would be a -15x, and then -5 times 4 is -20. So you can do it that way, and you can get your answer as 6x squared. 2x terms you can combine, 8 minus 15, that would be -7x, and then a -20 there at the end, and have your final answer as that. The other way you could do it is just big time distributing. So distribute the 2x term first, so 2x times 3x, which of course makes 6x squared again. 2x times 4, which of course makes 8x, as we've established. Then distribute the -5. So -5 times 3x would be -15x, and -5 times 4, which makes -20. So it's the same terms. It just depends on how you want to organize it. You can, of course, combine your x terms again, and you still get the same answer as a result. Final answer being 6x squared minus 7x minus 20. All right, so let's look at multiplying the next one, number 2. So number 2, same idea. You can either make a table, which would probably be the easiest way to do it here, or just go ahead and distribute a bunch. So I'm going to make a table, 2x squared, -3x, 6, and then x 3. So on top, I have all the terms from this polynomial, the 2x squared, the -3x, and the 6. And on the side, I have the 2 terms from the other one, the x and the 3. So multiplying all this out, 2x squared times x, that's still, remember, you're still multiplying, so it's still going to be a 2, but x to the third. 2x squared times 3 is 6x squared. -3x times x would be -3x squared. -3x times 3 would be -9x. And last column, 6 times x would be 6x, and 6 times 3 would be 18. All right, just got to put our final answer on the paper now. And we'll do that through just, again, combining the terms. So 2x to the third is no other x to the third term. I've got a couple x squareds, though. 6 minus 3 would be 3, so that's going to be 3x squared. Couple x terms, -9 plus 6 would be a -3x, and then the 18 at the end, plus 18, as our final answer. Okay, so now let's subtract, right? So when I subtract, what I like to do is distribute the negative. That way I don't have to, think twice about how I'm going to combine like terms. So let's distribute this negative first. We'll have a -2x squared, -5x, and then a +1 from distributing that negative. I'll bring these other ones down. Remember, there's no negative in front of this group here, so there's nothing to distribute. It's just keep it the same. And now at this point, it's just find your like terms and put them together. So like terms that we have would be, well, there is no like term for x to the third, so it's going to remain x to the third. There is no like term for the x squared term, so it's going to remain a -2x squared, because remember, you subtracted it, which turned it into a -2x squared. Then we have a couple x terms. We got -4x and -5x. So we can combine those. -4 and -5 combine to make -9x. And then we have a +1 and +1, which means +2. So there's our final answer. Just remember to distribute the negative. That's the main thing there. And then just combine like terms. Let me write that a little higher up. X squared x to the third minus 2x squared minus 9x plus 2. Okay. Number 4, perimeter is just adding up all the sides. So we've got 3 sides here I need to add up. So let's do that. 5m plus 3 minus m plus 2m minus 3. So it's just all 3 sides, as you can clearly see, just being added together. And at this point, it's just a matter of combining like terms. I erased those. Let me fix them. All right. So I've got m terms. 5m minus 1m plus 2m. So 5 minus 1 plus 2 means that this is 6m. And then my other like terms I have are plus 3 and minus 3. Plus 3 minus 3 makes 0. So plus 0, or basically same thing as just 6m being the final answer. Very, very simple that one is. Number 5, solve the compound inequality, then graph the solution set. So you won't have to do any graphing on tomorrow's exam, but you will see graphs as your answer choice, and it's smart to obviously pick the right one. So remember, it's an or problem. So any multiple choice question that has like shaded in between, you should automatically just cancel out because that's not going to be an option. An or problem means that your shading will go opposite directions on our number line. So keep that in mind. So if that helps you narrow it down, that's good. Now, when we solve it, we solve these two things like normal equations. So we're going to add 3 to this one on the left, just so I can cancel it out and have s less than, but remember to add 3 over here. Negative 7 plus 3, be careful with your math there. It's negative 4. So s is less than negative 4. So keep that in mind. We'll graph that in a second. The other inequality, we're going to divide by negative 4 to cancel out this negative 4. Now, you do need to remember that if you divide by a negative, that flips the sign around. So s is greater than or equal to negative 2. So let's put this on the number line. Obviously, on tomorrow's exam, you'll already see the number line drawn and completed. You just have to pick the correct one. So if it's less than negative 4, we're going to have an open circle at negative 4, and it's going to be shading this direction. If it's greater than or equal to negative 2, then we're going to have a closed circle at negative 2, and we're going to be shading this direction. So that's what the answer choice would look like on tomorrow's exam. Graph the system of linear inequalities. So this one is a matter of making sure you know your slope-intercept form. So this first graph, it has a y-intercept at 3. So we're going to put our dot there on the y-axis at 3. And it's got a slope of negative 2, meaning negative 2 over 1. So down 2 and right 1. So down 2, right 1, puts us right here. Right? And so we'll look for a line with this slope, down 2, right 1. Remember, you don't have to make the graphs tomorrow on your exam. You're just going to have to identify the correct slope, y-intercept, obviously make the right choice. Now, this line will be a dotted line or a dashed line. And you'll see that it should be shading below. It's y less than, so you're going to be shading below. So that would be, something like this side of it. All right. You get the idea? Okay. Lots of shading there. All right, here we go. Good. All right, and then the other line, let's use blue, I guess, so it's a little different. The other line, same thing, y-intercept form. So the slope is at, or not the slope, but the y-intercept is at negative 4. And the slope is 5, meaning it's 5 over 1. Now, positive means up. So it'll be up 1, or I'm sorry, up 5 and right 1. So count up 5, 1, 2, 3, 4, 5, right 1. That's going to overlap this point here. And then we can do one more time with 5 over 1. Puts us right there. This will be a solid line, right? And it's y is bigger than, y greater than. So we're going to shade above our line, which if you think about take any point and then draw a line up, you've shaded that side. So above that line is going to be this left side of the line. So remember, you don't have to make the graphs on the exam, but you're going to have to make sure you pick the right one, right? You're going to have to make sure it matches what you need. So be able to understand the slope-intercept form, be able to understand open or, dotted lines or solid lines. Make sure you understand which direction the shade. Understanding those things is going to be key to picking the right one. All right, number 7 is solve. Now you can solve this, several different ways. So you kind of have options here. I'm going to pick the way that I think would be the fastest, and based on the way this problem is set up, I think elimination will work best. But substitution would work really, really well also. It would just take a little longer to do substitution. But if you like using substitution, you can. But I'm going to choose elimination because all I have to do is add the equations together. And I don't even have to change the equations because the y's will cancel out. Negative y plus y will become 0y and eliminate. Remember, don't use elimination unless you have something that cancels out. So if I add these together, negative 3x plus 5x is going to be 2x. Negative y plus y is going to be 0y, essentially, right? Cancels out. I'm just going to erase it since it doesn't exist. And then 12 minus 10, or 12 plus the negative 10, same thing, is 2. So I have 2x equal to 2, which means when I divide by 2, I get x is equal to 1. All right, now that's not the final answer, but we can narrow it down because we have, remember, it's multiple choice, right? So if I have, answer choices with x being 1, I'm going to narrow it down to those. But if I have answer choices where x is not equal to 1, right, then I'm going to cross this off my list. So I can at least narrow it down. So keep that in mind. But we still need to know the y value. So what we're going to do is take this x value, plug it right back into one of those equations, and solve. I'm going to pick the second equation because it's got fewer negatives in it. So 5x plus y is equal to negative 10. I'm going to plug the 1 in for x. So 5 times 1 plus y equals negative 10. That's going to be 5 plus y equals negative 10. And subtract 5. So this is y is equal to negative 15. So 1, negative 15 is our answer. Okay. It's taking a while. It's gonna be a long exam. Okay, so number 8, this one would work best with substitution because the y is by itself and it's equal to x plus 5, meaning that we can go ahead and just plug this x plus 5 in for y. So if I rewrite this equation, it'll be 3x plus x plus 5. Now I don't need these parentheses because I'm not multiplying by anything, so I'm just gonna erase them. But yeah, this is where y was, right? It was 3x, or I'm sorry, it was 3x plus y equal to 13, but my equations are now 3x plus x plus 5 equal to 13. So this is y because that's what y equaled, right? So now we're just going to solve this equation. We have two like terms, the x terms, we can combine them. 3x and 1x makes 4x. Going to bring down the 5, have that equal 13, right? And it's just a regular algebra problem, guys. Subtract 5. This is going to be 4x equal to 8, and then divide by 4, so we know that x is equal to 2. Again, narrow it down, okay? So if you have your answer choices, any answer choice that has x equal to 2, now you can select them. All right, but if you still need more information, remember you can just plug this back in. It's not going to matter which equation you plug back into, but I will pick the first one because it looks like it'll be easier to use. So y equals x plus 5, but I'm going to plug 2 in for x. So it's going to be y equals 2 plus 5. So y is equal to 7. So our answer here would be 2, 7. X equal to 2, y equal to 7. All right. Use the elimination method. Now, again, you don't have to use the elimination method. You just have to get the right answer because it's multiple choice. However, the elimination method is by far the fastest and easiest way to do this one. Because for the same reasons in number 7, if I add these equations together, I'm going to get the y's here, in this case, to cancel out. Because negative 5y plus 5y will become 0y and go away. So this is what we do. We're going to add them up. So negative 2x plus 4x is going to be positive 2x. Negative 5y plus 5y is 0y, so it's going to disappear. And negative 11 or negative 13 plus 11 is negative 2. So divide by 2, we have x equal to negative 1. So same as before, just plug the negative 1 back into one of those equations and find y. So I'm going to plug it in the second one. So 4x plus 5y equals 11. Plugging the negative 1 in for x. So 4 times -1 plus 5y equals 11. This is -4 plus 5y equals 11. A lot of algebra here, but it's just algebra, right? Add the 4 to cancel it out, so 5y equals 15. And then divide by 5, we end up with y is equal to 3. So the answer is -1, 3. All of this right here, although I did it kind of quickly, you guys should already know how to do. Excuse me for writing it kind of fast. I do want to just keep the video short. I don't want to spend time on things you guys should already know how to do. Like the whole thing. Jokes. All right, number 10. Solve the system by graphing. So this one's going to take a little bit of time because we have to get these two equations in slope-intercept form, right? Something like this. Because it was very easy to use slope-intercept form on number 6, remember, when we had to graph it? So we need to get those two equations here to be like that as well. So -3x plus 3y equals 2. So let's do this. We're going to add 3x first to move the 3x term over. So that's now going to be 3y equal to 3x plus 2. So remember, it's just 3x over here and 2 over here. So that's why you see the 3x and the 2, right? 3x plus 2. Now we're going to just divide by 3 to cancel this 3 out. That leaves us with y equal to 1x plus 2/3. Okay. I apologize for not making this better. I thought I fixed, because I made this problem up. I thought it was going to be 1 without a fraction, but it's fine. If we're going to just roll with it, y-intercept is 2/3, so let's say something like right there, and then we're going up 1 over 1. So just keep going like up to a 2/3 mark. Not a big deal. Obviously, on tomorrow's exam, you won't have a fraction y-intercept, but yeah, it's okay. It's fine. Okay, there we go. Okay. And the other equation, so x plus y equals 3. So this is a much simpler one. Just subtract the x, we get the y by itself. Y is equal to -x plus 3. So the y-intercept is at 3, and it's -x. So -1. The slope is -1 over +1, so it means it's down 1 over 1. So it'd be like this. Now, tomorrow's test, again, you won't see those fractional ones like that first one. But you get the idea, right? Rearrange it into slope-intercept form. That's the main thing. If you can do that, you can graph your lines, no problem, I would hope. Okay. Number 11. The equation y equals -11.49 plus 659.99 gives the price y of a particular model of television X months after television first became available. What is the real-world meaning of the y-intercept? It's supposed to be an x here. Yikes, that's a typo. Okay, so equation is y equals -11.49x plus 659.99. This is our y-intercept. This is our b, right? Because it's mx plus b. So the -11.49 is the m, is our slope, and the 659.99 is our b value, which is our y-intercept value. So the y-intercept is 659.99. And since this equation is the price of our TV over time, right, after X months since it was first available, what this indicates to me is that, the y-intercept being 659.99 means this is what the price was at 0 months. This was the price at the beginning, right? And then this is the price that it's decreasing by every month. It's decreasing by about $11.50, right? Close to $11.50 every month. But the y-intercept, that's the most important thing, with the real world meaning of the y-intercept. At 0 months, the price was this, right? So that means that this was the original price of the TV. Original price, right, of TV, or the price it started off with. Right, number 12. The graph shows the change in temperature y of an oven preheating over time in X minutes. Identify the slope and y-intercept. Explain what they mean in its real-world context. All right. So the slope of this line I can find by looking at these 2 points. So from 150 to 190, that's an increase in 40 for the y's, right? Remember, slope is just y2 minus y1 over x2 minus x1. But if you just do the math in your head, 190 minus 150, right? 190 minus 150 means the change in y is 40, right? You can see that. You can see that it increased 40 in the y. And then the x's, obviously is an increase of 1 because you're going from 2 to 3, right? But you can still plug it in the form if you want, 3 minus 2, right? But still, it's an increase in 1. So the y is increased 40, the x is increased 1. So 40 over 1. So our slope is equal to 40. Now, what that means is this is the rate temperature increases per minute, right? It's increasing 40 degrees per minute. Our y-intercept, I don't know, about 75, 70? It's really tough to tell, but, it's close to like maybe 70. So we'll say y equals 70, 75, right? This is the temperature at 0 minutes. So this is the temperature before we start preheating. So this is the temperature in oven before we preheat, right? At the very beginning. We turn our oven on and automatically it's already 70 degrees. Okay? I have to erase some of this. But anyway, you get the idea, hopefully. All right. Number 13. Gabriella is shipping fruit baskets to her friends for Christmas. The graph shows the cost of shipping the fruit baskets for a number of friends. Find the slope of the line. Then tell what the rate of slope represents. Remember, all these are multiple choice. So tomorrow, when you're looking at it, try and read it. Try to understand which ones make sense and which ones don't. Now, the slope of this line, remember, change in y over change in x. So 16 minus 10, or what's the difference from 10 to 16, right? It's an increase in 6. And our x values are an increase in 3. So our slope is simply 2, right? If you want to use the formula, you can. 16 minus 10, 6 minus 3, it's 6 over 2, which obviously, 6 over 3, which is obviously equal to 2. So you can use a formula, but you can sometimes just eyeball it, right? It's increasing by 6 as it increases by 3. Now, y's come over x's. So 6 over 3 is 2. Now, what does that mean? What it means is that, one more basket, right? If we get, for each basket we have, it's an increase in $2. So basically, this 2 means that it costs $2 to ship each additional basket. Right? I mean, think about it. One basket costs $6 to ship. The second basket costs $8 to ship. So for every additional basket, it's an additional $2 to ship. So it must be $2 per basket, essentially. $2 per basket to ship. Let's do number 15. No, 14. Okay. The graph shows the relationship between x and y. Basically, what you're going to see is answer choices that are all slope-intercept equations. And you're just going to have to pick the slope-intercept equation that matches this one. So the idea is just find out what the slope and the y-intercept are. So if we look carefully at this graph, we can see the y-intercept is at positive 2. So that's a clue that we need. And if we also look carefully, we'll identify that the slope seems to be going up 2 and right 1. So the slope seems to be 2 over 1, right? Up 2 and right 1. So our y-intercept is 2. Our slope is 2. So our inequality has a solid line, and we're shading below this line. So this tells me, with all those things considered, right? Solid line, shade below, that this would be y less than or equal to, because y less than or equal to means it's shaded below and it's a solid line, 2x, because our slope was 2, plus 2, because our y-intercept was 2. So putting all those things together, this would be the inequality equation, or the inequality of our graph. Okay, so all these things need to be considered. What is the y-intercept? What is the slope? Is it a solid or a dotted line? Is it shaded above or below? You have to know all these things because if you had, an answer choice that says y is less than 2x plus 2, it's very close, right? It's got the y-intercept correct. It's got the slope correct. It has a shaded part below correct. However, because it doesn't have the line underneath it, if it was just this, it would be indicating it's a dashed line. And look carefully, our line is not dashed. Our line is solid. A solid line would have to have the equal part underneath. So all these little details you have to be aware of. All right, so we're going to graph number 15. So this one's a little similar to number, I don't remember, maybe it was number 9 or something, number 6, number 9, where we have to rearrange this in slope-intercept form and simply graph it. So negative 4x plus 2y is greater than or equal to negative 6. So rearrange it. Hopefully we can do this by now because it's something that appears all over this test. 2y is greater than or equal to 4x minus 6, because remember, you got 4x, you got a minus 6. So just those two terms there. Divide by 2. And we have y is greater than or equal to 4 divided by 2 becomes 2x, and 6 divided by 2 becomes 3, so minus 3. So we're going to graph this. Our y-intercept is negative 3. Our slope is positive 2, meaning 2 over 1. So up and right. Up 2 and right 1. So that's going to put us up 2, right 1. Puts us here. And we do that again. Up 2, right 1. Up 2, right 1. Up 2, right 1. Right. This is a solid line because we have the equal to portion of our inequality. So it's going to be a solid line. And y is greater than, so we are going to shade above this solid line. So we're going to shade this part of it. So again, you do not have to make any graphs on tomorrow's test, but you will see the graphs, and you're going to need to make sure that you get the correct slope, the correct y-intercept, the correct line, the correct shading. Okay. Obviously, it's going to come down to really, can you rearrange in slope-intercept form? Because at this point, then you're just matching it with the graph. It's very basically the same thing as number 14. 14 was the opposite of this, but on a multiple choice test, they're essentially the same question. What are the intercepts of the linear function? This is pretty easy. So the y-intercept is clearly 2. Y-intercept equals 2. And the x-intercept is definitely 1. So x-intercept equals 1. That's a very easy question on the test tomorrow. It is that easy on the test tomorrow. Just obviously make sure you understand the y-axis is this one, the x-axis is this one. Okay, well, that should help you. Okay. Number 17. We're getting there. What are the slope and y-intercept? Okay, so y-intercept on this line is definitely 5. And our slope, it's kind of hard to tell. Let's see. Here's a good point. Our slope from this point to this one seems to be going down 5 and right 4. So if we're doing rise over run, right, our rise is negative 5, our run is 4, our slope is negative 5/4. So that's the answer on the test tomorrow. Y-intercept is 5, slope is negative 5/4. So just make sure you can do that as well. Give domain and range. So the domain of this one, remember, is how far left and right this goes. Does not matter how far down or up it is. Okay, it just matters if you kind of if we were to squeeze this whole thing flat, right? How much of this x-axis would it use? So if we did that, the furthest left it goes is negative 3, and the furthest right it goes is positive 2. Now you'll notice a closed circle here at negative 3 and an open circle here at 2. So our domain would say something like negative 3 less than or equal to x less than 2. Because x goes from negative 3 to 2, it equals negative 3, thus the less than or equal to, but it does not equal to 2, so which is why it's just less than. Now our range doesn't matter how far left and right it goes. We just care about how far up and down it goes. So the highest and lowest. So the lowest it gets is -5. Again, equals -5 because of that closed circle. And we're not even paying attention to this one here, right? The 2 doesn't even matter because it's not the highest point. The highest point is up here at 4. And it does equal 4 because it does hit 4. So our range is from -5, and it's our y-axis, and it goes up to +4, less than or equal to +4. So that is our answer. Okay, just drawing like lines and stuff. All right. There we go, right? -3 to 2. And, well, let me do it on the number line, right? -3 to 2. And -5 to 4. Kind of frame it in there for you. All right. So give a reason for each missing step. So what's happening here? We have the equation, right? Solving for x. And here we're adding 24 to both sides. Adding 24 to the left side, adding 24 to the right side. This is the addition because of adding, right? Addition, property of equality. And then this one here, you're dividing both sides by 6. So you can do that based on the division, property of equality. So it's a really simple question. Just basically, what is this, right? It's addition. What is this? It's division. You guys should be able to handle that pretty easily, I would hope. Okay, almost there. Number 20. Determine whether the graph represents a function. Well, if everybody knows the vertical line test, you would know that this fails the vertical line test. This is simply no. It's not. It'll be a yes or no question on the test as well. So 50-50, hopefully you can get it right. What are the x-intercepts of the graph? Now, it's phrased x-intercepts. I know that's going to confuse us, so 21 and 22. But really, we're just solving for x on both of them. You saw this on one of the review sheets I handed out. You're just taking each of these and setting them equal to 0 to solve it. So x minus 6 equal to 0 and x minus 9 equal to 0. So don't mind the weird wording. It's still asking that same question, though, right? Take each of these and set them up equal to that 0. So adding 6, we end up with x equal to 6 as an answer, and then this one is adding 9. We end up with x equal to 9 as an answer. So our two answers are x equals +6 and x equals +9. Same thing here, just take each of these and set them up equal to that 0. So x plus 1 equal to 0, x plus 7 equal to 0. So subtract 1, and we have x equal to -1. Subtract 7, and we end up with x equal to -7. So our two answers are, of course, -1 and -7. X equals -1, -7. Number 23, subtract. So this is very similar to number 3. You'll notice that this, even though this is really weird terms, right? These are like terms, right? It's an x, y to the third. It's x, y to the third. So they are like terms, which means you just combine them, right? So all you're doing is subtracting 5 minus 7. 5 minus 7 is just -2. So it becomes -2 x, y to the third. And that's it. Because of subtraction, you don't change the term at all, right? It's going to remain x, y to the third. That's not going to be any different. You're just simply subtracting the numbers, okay? 5 minus 7. You're doing the same thing in number 24, but remember what I like to do is distribute this negative since we are subtracting that group. So minus 7a squared and then plus 7a because subtracting a negative number would make that plus. Bring this one down and just combine like terms again. So here your a squared. It's 8a minus 7a, or I'm sorry, 8a squared minus 7a squared. 8 minus 7 is 1, so it'd be 1a squared. And then you have -5a plus 7a. So again, be really careful. That's going to be the part that messes you up, if anything, is this 7a. You know, the fact that it's adding and not actually minus like it was originally, right? Because subtracting a minus makes it turn into that plus. So -5 plus 7 is +2, so this would be plus 2a, and that's our answer. A squared plus 2a. And then, of course, finally, which of the following is not a function? So basically what you're looking for here and on the exam is any duplicate x's, not y's. It doesn't matter at y's. Duplicate x values. So you'll notice 3, 4, and 9. There's no duplicates there, so this is clean. 4, 9, 8, all those x's are are different, so that's good there. You have 3, 5, and 3. So here, look, you've got a pair of 3s, right? 3x here and a 3x here. That's a duplicate, right? This 3 goes to 1, the other one goes to 6. That's representative of not a function. And you can just double check the last one, -1, 14, and 2. They're all different. So it doesn't matter the y's, right? You can, like in B, you have 7s repeating, but that's okay. That doesn't really matter. It's the duplicate x's that are a no-go. That's what we're looking for. And that's what we see in answer choice C. So look for that on the test as well. That's it. If you guys can do all of that, you can pass the exam, which I hope you can. Good luck. I'm yawning. All right, bye.